Regarding Rspmatch, we have as an input the target spectrum that we previously computed in the target spectrum panel, and this is automatically imported in the Rspmatch panel. After this, we also need an input accelerogram, meaning an input ground motion, because we want this ground motion to match the target spectrum. So we can import this ground motion from an external file by clicking import ground motion here and importing from a txt file. We'll see this panel that we saw already a lot of times, where we have this first line to be inserted, the last line of values, but these are automatically retrieved by the application. And we also insert the content type. In this case is time plus acceleration, as you can see, with acceleration column is the second one and the time column is the first one. And the input acceleration unit is g, and we want acceleration unit to be still g in the output, so we don't change this output acceleration value. After doing so, we can click OK, and we have also our input accelerogram. Now we have to decide the Rspmatch parameters, for example, damping, maximum number of iterations, tolerance, convergence factor, and the type of model. We have here different model. You can leave it as it is because this is the recommended types of parameters, but you can choose at your choice. Also the alpha function, you can choose some parameters and matching settings, but at the end you will run the Rspmatch by clicking on this button. You will see a number of iterations equal to the value that you inserted here. In this case is 10, and at the end you will see the final result with the matched accelerogram and the reference one on the other in the same plot. But you can also analyze its result in terms of matching in the target spectrum, because we wanted to match the response spectra of our accelerogram as near as possible to the target one. And we see that the gray one is the original, the blue one is the matched one, and the matched one is much more similar to the target one. So this was pretty good, even if we have a max misfit. It is in this section that it is very different from the target of 47%, and a mean misfit that overall is very good because it's lower than 10%. And we can also see the log, the iteration log, and the error at each iteration. In this case, it didn't converge just because our tolerance was very low, was 5%, and our best misfit in the mean misfit was 9%, so it did converge, but still it was a pretty nice result. Again, you could do the same thing by importing the ground motion instead of from an external file, from an internal row in the database selection, and clicking actions in the toolbar. You have to click then go to Rspmatch, select the component. This will import the ground motion that we selected, and we could run the same exact steps. After we finished, we want maybe to export our results, so we click here on file and then export results. And after selecting a destination folder, for example download, you click save, and this will download a folder with these files inside, so basically all the plots and the values that we saw in the application.